Welcome to Genique. So this is our next question. So electric field is given. Okay, it is traveling in X and Z. So it is given here X and Z direction. Okay, we have to find the magnetic field. Okay, so here an EM wave, right here an EM wave has, the question includes what? The question includes an EM wave has electric field E of x comma t is equals to this one 5 sin omega t minus 3x plus 4z ay volts per meter. Okay, traveling in free space. Then find the h of x of z comma t. So that means the EM wave is traveling in both x and z direction. So if you observe this, it is traveling in free space. Because it is traveling in free space, what is this? The amplitude is constant. It is not a function of z. The amplitude is not a function of z. Now observe this. What about this? It is omega, and the next one is what? This is called as what? There are two directions. One is traveling in which direction? The first one is what? The first one is, it is plus ax direction and minus az direction. You have to notice this. Okay, the wave is traveling in, if there is a minus, plus ax direction and minus az direction. So it is a inclined propagation. Okay, it is not a straight propagation, it is inclined propagation. If you observe this, see, if you observe this, now what will be the propagation direction? The propagation direction will be, you have to write the propagation direction. So from this you have to identify the propagation direction. The propagation direction is equals to what? The propagation direction is equals to positive x direct 3ax. Okay, 3ax minus 4az. You have to write like this. It is 3x direction, right? So that's why I have to write ax and I have to write minus az, right? Okay, I have to write minus 4az. So this is the vector. In this vector, the propagation is directed in this vector. But always the propagation must be written in terms of the unit vector. The propagation direction must be written in terms of the unit vector. Okay, so it is a vector of magnitude how much? It is a vector of magnitude how much? 3ax minus 4az. So the direction must be always specified in terms of the unit vector. So that's why the propagation direction must be is equals to what? Root over 3 square plus 4 square. So this will be 3ax minus 4az divided by, it is 5. So this is the propagation direction. Why I am dividing with this? Always either field direction or the propagation direction always specified in terms of the unit vectors. But if you write like this, it is not a unit vector. Okay. So from this you have to convert into unit vector. So to convert into unit vector, I have to divide with the magnitude of this. So this is the magnitude like this. So from the above expression, there are two betas here. Already I said the multiplication factor of the distance parameter is beta. The multiplication factor of the distance parameter is beta. There are two betas there. So what is beta? Beta 1 is equals to 3 and beta 2 is equals to 4. Then what will be the total beta? The total beta will be is equals to root over 3 square plus 4 square. You have to take the like this. The what is the meaning of this? Let us suppose how the propagation is. The propagation direction here is, let us suppose this is z direction and this would be x direction. How the propagation is existing? The propagation is existing plus ax minus az direction. So plus ax minus az direction means what? Like this. Okay, it is inclined. propagating. In which direction? Plus AX. Plus AX. This is Z, right? This is Z. And this is X. Okay. Why I have taken this Z after Z? It must be X. It must be Y. Okay. So it is traveling in positive X direction and negative Z direction. Then how it would? It would look like. So we have taken, this one is wrong. See how the wave will be traveling. That wave is traveling in which direction? Positive X direction and negative Z direction. This is positive Z direction, negative, this is X and Z. How the wave is traveling? The wave is traveling in positive Z direction means this one, and negative X direction, positive X direction means this one. Okay, like this. Positive X direction means this one and negative Z direction means this one. Okay, so this is what is the unit vector? The unit vector is 3x. No need to write this figure. So this is the unit vector. This is the propagation direction. Okay, now so this is beta. So in this is the total beta. If it is total beta, then what it will be? It will be beta x, the phase shift constant in this direction. So what about this? This would be beta z. So what is this beta now? The beta now would be this square plus this square. So that's why I have written. Understand? So wherever there are two betas, you have to follow this. Okay, the square root of 2 beta square. So this would be how much? This is 5. The total beta is 5. This is the B total. Okay. So now what we have to find? We have to find the magnetic field. Okay. So already it is given in eta is equals to what? 120 pi. It is free space given. So that's why eta is 120 pi. So now what is H? H is equals to E by eta. So this implies H of x comma z comma t is equals to what is E? 5 divided by 120 pi. 5 divided by 120 pi sine omega t minus 3x plus 4z. What would be the direction now? So identifying the direction of the H field is the challenge. Okay, every time. So don't write this wave. See, always the electric field must be perpendicular to the magnetic field and it must be perpendicular to the propagation direction. Always. And don't take this is y and this is also y. Both cannot be in the same directions. And these both will not be in the propagation directions. In the direction. Okay. So this is the magnitude. The magnitude will be 5 divided by 120 pi because eta by E by eta sine omega t minus beta z. So you will get the same phasor here. Then what will be the direction of this? Then what is the direction? For finding the direction we know. What is the E field direction? E field direction cross H direction. H field direction is equals to the propagation direction. Okay, what is the E field direction? The E field direction already given, it is AY. The E field direction already given, it is AY. Okay, cross, we don't know this H direction, but it is equivalent to what? The propagation direction. What is the propagation direction? The propagation direction is given as 3AX minus 4AZ divided by 5. Observe the approach. So AY cross this thing is equals to this thing. To get this 5, I am rearranging this. See, write this. Here I have to get, because it is 1. To get 1 by 5, I have to write 1 by 5. To get AX, what I have to write? AY cross something is equals to AX. It must be AY cross minus AZ. So it must be minus AZ, but minus 3az minus 3az. If I multiply ay dot az, ay cross az, this will be what? Yeah, not minus az, right? If I multiply ay cross az, what I will get? Ax. Ay cross az is ax. 3 is there, that's why I have written 3. To get minus az, what I have to write? I have to write ax plus 4ax. If I cross product ay cross ax, if I cross product ay cross ax is minus az. So like this. So because 3 is not there, 3 is there, so that's why I am multiplying with 3. Because 4 is there, because that's why I am multiplying with 4. Because 5 is there, because I am multiplying with this. So if I multiply these two, you will get this. In such a way, you have to adjust that. Okay. So from this, now what is the direction? So this will be the H field direction. So this is the H direction. So that means what? So this is, you have to write this one here. You have to write this one here. What is this value? This is 3az plus 4ax divided by 5. Then what will be the final answer? Here 5 will get cancelled. 5 will get cancelled. Here you will get 1 divided by 120 pi sine omega t minus 3x plus 4z 3az plus 4ax. So this is the final notation. Understand? So this is the actual answer for this. Okay? So like this, you have to approach these kind of problems. Okay? I hope you got this. And you can also divide these two. Okay? Multiply with 3az to this one and multiply with 4az to this one. So either if you leave this like this also, the answer is correct. Okay? Okay, thank you. Hello, welcome to Genique. This is the question. Next question. The loss tangent for the medium is 1.732. Then the phase difference between the E and H will be. We have to find the angle between the phase difference between the E and H. Okay? See, what is this meaning of the phase difference between E and H? Generally, mostly the people will misunderstood that. Okay, what is the phase difference between E and H? They may think that it is the phase difference between E and H will be 90 degrees. It is not. It is, he is asking about the phase difference with respect to the time. Okay, the phase difference with respect to time, not in space. Always the electric field will be the electric field. Let us suppose the electric field, this is E direction. The electric field direction perpendicular to the magnetic field direction. The electric field direction perpendicular to the magnetic field direction and perpendicular to the propagation direction. If it is E field, then this would be H. How the magnetic field will be? The propagation will be. This is the propagation out of the board. This is the electric field direction E. Then what about this one? This is H. Always this follows. Electric field direction, magnetic field direction, propagation direction. Okay. But see, if you observe this, these two are orthogonal in space. Okay. E is perpendicular to H is perpendicular to P. They are orthogonal in space. In space. Space means in x, y, z, like that. So what he is asking in the question, the phase difference means the phase will be varying with respect to time and space. We know already the phase of an EM wave, will be varying with respect to time. The phase of the EM wave will be varying with respect to space. Space means this one. See, he is not talking about this. He is talking about this. Okay, definitely, no doubt, always it will be perpendicular to 90 degrees. The phase difference is 90 degrees only. Okay, he is not asking about that. Everyone will know that E is perpendicular to H. He is not asking about that one. The phase difference with respect to the time. Okay, so that is the thing you have to notice here. Now come to the question. The last tangent for the medium is 1.732. Then the phase difference between the E and H will be. Okay, now come to the concept. What is the last tangent? We know the last tangent is equals to sigma divided by omega epsilon is called as the last tangent. What is sigma? The conductivity of the medium, omega epsilon, frequency and the permittivity. And it is given as how much? It is given is equals to what? 1.732. Okay, the last tangent of the medium is given. Okay, so now we have to find the phase difference between E and H. So how can, what is E and H? To find the phase difference between E and H, okay, so you know, first of all, what is the eta? So we know eta is equals to, what is eta is equals to? Eta is equals to root over j omega mu. You will come to know why we have taken eta. Okay, eta is equals to j omega mu divided by sigma plus j omega epsilon. Okay, so now if you write like this, see what is j? J represents a 90 degrees. So if you take the magnitude and phase, it is a complex term. It is generally a complex. So complex means you will get some magnitude. What is the magnitude? Magnitude will be omega root omega mu. Okay, the magnitude will be root omega mu divided by sigma plus sigma square root over sigma square plus omega square. So you will get some magnitude, numerator magnitude, denominator magnitude. Here we are not concentrating on the magnitude. Okay, now what would be the phase? Phase, see, what I am not talking about the magnitude here. What is the magnitude of this one? Root over magnitude of this one is what? J omega mu. Okay, root over j omega. Here what is the magnitude? Sigma plus j omega epsilon, sigma square plus omega epsilon square root over. Okay, so this is the magnitude. I am not talking about the magnitude. Then what will be the phase of this? The phase of this will be, observe this, it is under the root. It is under the root means, what can I write? This is, what is the phase of, first I am not talking about the root. First of all, find the phase of this. First of all, find the phase of this. Okay, so how can you find the phase of this term? This term. So here the phase of the numerator is tan inverse imaginary by real. Imaginary is omega mu divided by real is 0. So 90 degrees. So imaginary term 90 degrees for the numerator. For the denominator, what is the phase? So tan inverse imaginary by real. Imaginary is omega epsilon divided by the real. But these are, this is the numerator, it is in the denominator. When the numerator denominator terms are there, the phases will be, what happens? The phases will be subtracted. The numerator phase minus denominator phase. What is the denominator phase? Denominator phase is tan inverse of omega epsilon divided by sigma. But this entire term is in the root. Suppose if any phase angle is there in the root, then you can write theta divided by 2. You have to note this. Okay. So if any phase is under root means you can write the phase divided by 2. So we cannot find the root of the phase. First of all, that's why. Okay, you have to remember that. Okay, here root over the phase means what? The phase divided by 2. Root over any phase is equals to what? The phase divided by 2. But this entire term is in this one. So that's why you can write by 2. Understand? So that means what? This is the magnitude, and what about this? This entire one is a phase. Understand? So that means how can I write? This is eta. This eta can be written as, because it is a complex value, eta can be written as magnitude of eta and angle theta. So that means what? This eta can be written as some magnitude into polar form. Phase. So that means, what about this? So the magnitude is this one k and phase is this one. Here the phase is this one. Theta is equals to 90 minus tan inverse omega epsilon divided by 2. But we know that, what about this eta? The eta can be written as, it is equivalent to E by H. Understand? It is E by H. So what is E by H? E by H is this one. It is equals to this one. Okay? But E by H is complex means, see, E by H equals to eta. But it is equals to this one. But that means E by H is also complex. Understand? So I can write this is equivalent to E by H mod at an angle theta. Understand? So that means this theta is nothing but the angle between E and H. What this magnitude? The magnitude is representing this is the magnitude. What is this theta? This theta is representing the angle between, the phase difference between these two with respect to time. Understand? So this is the thing you have to notice. So from now onwards, see, E by H equals to eta, but it is a complex value. Because it is a complex value, I can write this one. So this is equivalent to this one. Okay. So now eta's phase, we can conclude that the eta's phase is equals to what? So eta's phase is equals to the phase between E and H. You should remember this forever. Eta's phase is equals to the phase between E and H. Okay. So the phase between E and H. So from this, what is the phase difference between E and H? The phase difference between E and H is theta is equals to, the theta is equals to tan inverse, sorry, what is this is given, this is 90 minus tan inverse omega epsilon by sigma divided by 2. Okay. So here it is given, it is 90 degrees. It is 90 degrees. Okay. 90 degrees minus tan inverse of omega epsilon by sigma. Sigma by omega epsilon is the loss tangent. Okay. So from this I can write 1 divided by this one means what? 1 divided by 1.732. So divided by 2. So this is equal to what? 90 degrees minus tan inverse 1 divided by 1.732. 1.732 is nothing but what? It is root 3. You can also use the calculators, no problem. Okay. So here it is tan inverse 1 divided by root 3 divided by 2. Tan inverse 1 divided by root 3 is what? It is 30 degrees. So that means 90 degrees minus 30 degrees divided by 2. So this is 60 degree. 90 degrees minus 60 degrees divided by 2. That means it is, answer is 30 degrees. Understand? So like this, you have to know what is the phase difference between, whether always the electric field and magnetic field will be always orthogonal to each other. Orthogonal means they are in space. Okay, we know that. But he is asking about whether the E and H phase means. So we have to think for a while. Okay, it is not 90 degrees. So if anyone don't know this concept, so what is orthogonal space and what is orthogonal in time, then they may put 90 degrees. Understand? Now, what if it is a medium is given. Suppose in the medium, if the medium is a perfect conductor, a very good conductor, what happens? The answer is 30 degrees. Here further the answer is 30 degrees. Okay? But in the given question, what if the loss tangent for the, suppose in the given question 1.73 is not given first of all. Okay. Okay. Suppose, we forget about that question. Okay. Suppose what will be the phase difference between E and H for the conductor? Very good conductor. Okay. What happens? The phase difference between the very good conductor, what happens? Okay, what happens for the phase difference between the very good conductor? The phase difference between E and H for the very good conductor is, this is the question. Okay. Now what it will be? Observe this. For the very good conductor, what about this? Loss tangent. The loss tangent is more, because for the very good conductor, sigma must be greater than omega epsilon. So from this, what we can write? This is for sigma divided by omega epsilon is much greater than 1. Okay, the loss tangent is much greater than 1. The loss tangent is much greater than 1. Understand? The loss tangent is much greater than 1. So the loss tangent is much greater than 1 means, observe this, sigma is much greater than 1. So sigma is much greater than 1 means what in this expression, observe this, in this expression omega epsilon divided by this one, much greater than 1 means, so this will be much less than 1. Okay, so we can write this one tends to 0. So tan inverse of 0 is what? 0. Understand? Tan inverse of 0 is 0. Or otherwise you can also approximate this. You can only write the sigma, because the sigma is more when compared to omega epsilon. So only you will get 90 degrees. 90 divided by 2. So now what about this? This is 0 divided by 2. What is the answer? The answer will be 45 degrees. 90 divided by 2. The answer is 45 degrees. So this is the phase difference between E and H for the very good conductor. Okay. So this is a very, very well known question. What is the phase difference between E and H? Okay, for the very good conductor. So this is like this. Okay. So what is the phase difference means? What is the phase difference means? Suppose how the electric and magnetic field. Let us suppose this is electric field, this is magnetic field. See, what is they are in phase means what? They are in phase means they perfectly leave this point the same time. Like this. It will go like this, it will go like this. Okay. So there is a phase difference between these two. There is a phase difference between these two. Okay. How much? 45 degrees. So it is related to the time. So there is a time difference between reaching the axis. There is a time difference between the reaching the axis. Okay. That is the meaning of this. Okay. But they are perpendicular to each other. But it is going like this. After going this, it is reaching like this. Okay. Now, suppose in the given question, if the phase difference between, find the phase difference between E and H for the perfect dielectric. For the perfect dielectric. So perfect dielectric means what? Perfect dielectric or free space. What happens? For the perfect dielectric or free space, what happens? For the perfect dielectric, what is this loss tangent value? The loss tangent value will be 0 because what happens? This will be, the sigma is 0. Sigma 0. The sigma is 0. The loss tangent is also 0. Sigma 0. It is sigma 0. If it is sigma 0, J will get cancelled. What you will get? So J will get cancelled. Omega will get cancelled. So eta is equals to what? Eta is equals to root over mu epsilon. Mu by epsilon. So is there any difference between these two? Is there any difference between these two? See, observe this. See, there is no complex term, only the real term is presenting. So that means, what is the angle? The angle will be, it is 0 degrees. It is a real value, it is a real value. So the angle will be 0 degrees. The phase difference between these two is 0 degrees. Okay. So no need to come. Okay. So like this. So the phase difference between E and H is 0. So the answer would be 0. For what? For a perfect dielectric or a free space. Okay. So what is the meaning of? That means what? It is a purely real. It is a purely real. That's why we are getting 377, 125 ohm or 125 divided by root epsilon r. So what is the difference between E and H? The phase difference between E and H is 0 means what? How the electric and magnetic field will be? The electric and magnetic field will be like this. Let us suppose electric and magnetic field. So they always will be in phase. They will be perpendicular to each other, but they are reaching and leaving at the same time. They are reaching and leaving at the same time the axis. Okay, so this is the meaning of the phase difference between E and H. So this much story is presenting in this. Okay, I hope you got it. Okay, thank you very much.